Today, we're taking a deep dive into the hidden science that literally saves our lives on the road. It's a world of controlled chaos, super slow-motion cameras, and a whole lot of data, all aimed at one single, powerful goal. It's a pretty wild question when you think about it, right? Why would a company spend years and millions of dollars designing the perfect car, just to slam it into a wall on purpose? It sounds completely backward.
The answer is simple, and it's powerful. Because every single piece of crumpled metal, every shattered bit of glass, every airbag that fires, it all tells a story. It's a treasure trove of data that engineers use to make the next car you get into that much safer.
So here's our roadmap. We're going to start with why we crash cars in the first place, look at its kind of brutal history, break down a modern test, see how they decode the data, and then peek into the virtual future of it all.
Okay, so before we get into the nuts and bolts of how it all works, let's really dig into the most important question. Why? What's the end game for all this incredibly expensive metal-bending mayhem?
Well, the mission is pretty clear: to reduce injuries and save lives, period. Each test is this huge data-gathering mission. Engineers are checking out the car's structural backbone, what they call crashworthiness. They're making sure things like your seatbelts and airbags work exactly when and how they're supposed to. And all of that info gets boiled down into those simple safety ratings we see, which pushes car makers to build even safer cars next time.
But, this super scientific process, it wasn't always so polished. The history of crash testing is a really fascinating and sometimes unsettling journey from some pretty brutal experiments to the high-tech science we have today. So it all started pretty simply back in the 30s with the first barrier test. But the 1950s, that's when things got really serious. To understand what happens to a human body in a crash, early researchers used human cadavers. It's grim for sure, but it was a necessary step. By '59, things got more controlled with catapults. Then a huge step forward in 1978, the government created NCAP to standardize tests for all of us. But the biggest game changer? That came in the 90s, with computers powerful enough to simulate a crash before a single car was even built.
All right, so what does a modern crash test actually look like? Let's go inside the lab and see all this science in action.
Yeah, this is not about just driving a car into a wall and seeing what happens. It's a full-blown scientific experiment. A modern crash lab is this pristine, high-tech place where every single variable, from the speed of the car down to the last MPH to the lighting in the room, is controlled perfectly. They have to get repeatable, accurate data every single time.
And right at the center of it all is this guy, the anthropomorphic test device, or ATD. We just call them crash test dummies. But let me tell you, this is no store mannequin. This thing is an incredibly sophisticated piece of equipment, built with materials that act just like human bones and tissue. It's a data-gathering machine in the shape of a person.
And it is absolutely packed with sensors. You've got accelerometers measuring the G-forces on the head and chest. There are load sensors that tell engineers the exact force hitting a bone, like your femur, to see if it would break. And movement sensors check how much the dummy's chest gets compressed. Altogether, these sensors paint an incredibly detailed picture of what kind of injuries a real person might suffer.
But all that data from inside the dummy is only half the story. To really see how those forces are happening, engineers need eyes. And those eyes are an army of super rugged, high-speed cameras placed everywhere, all around the car, inside the car, underneath it, you name it.
And when I say high speed, I mean it. These cameras are typically shooting at 1,000 frames per second. A crash that's over in the blink of an eye, literally about 1/10 of a second, gets turned into this long, incredibly detailed slow-motion ballet of destruction. This lets engineers see exactly how the metal crumples and how the airbags deploy millisecond by millisecond. It's amazing.
And they don't just do one kind of test. There's a whole menu. The full frontal impact is a big one for testing the main safety systems. The side impact is like getting T-bone in an intersection. Then there's the offset crash, which is really tough because it focuses all the energy on just one part of the car's frame. And finally, the pole test mimics sliding into a tree or a pole, which can be a really, really dangerous accident.
Okay, so the crash is done, the car's a total wreck, and the lab computers are filled with terabytes of data. Now what? How do you take all of that complex information and turn it into something that you and I can actually understand when we're car shopping?
Well, all of that complicated data gets distilled down into something we all recognize: the star rating system. The measurements from all those dummy sensors are plugged into special formulas that calculate the odds of a serious injury. So, for example, a 5-star rating means you have a 10% or lower chance of being seriously hurt in that kind of crash. It's a brilliantly simple way to communicate a ton of science.
Now, as crucial as these physical tests are, they're also really expensive and they take a lot of time. And that's why the next great leap forward in car safety isn't happening in a lab at all. It's happening inside a supercomputer.
And the benefits here are just huge. I mean, think about it. Instead of building and smashing dozens of expensive prototypes, engineers can run thousands of virtual crash tests on a computer model. This lets them tweak and perfect a design at lightning speed, making the car safer before they even build the first real one. The physical test then just becomes the final exam to prove all that virtual work was right.
And the scale of this change is just staggering. Back in the early 90s, a car design might go through, say, 250 simulations. Today, that number is closer to 25,000. That is a 100 times increase. It just shows you how vital computer simulation has become to making our cars safe.
So we've looked at the history, the tech, the future, but let's bring it all home. Let's talk about you, sitting in the driver's seat. Why does all of this complicated science actually matter?
At the end of the day, surviving a crash is all about physics. It's about managing energy. And every single major safety feature in your car, the crumple zones that absorb impact, the super strong steel cage around you, the airbags, it's all a direct result of decades of crash testing. They're all designed to work together, like an orchestra, to soak up that violent energy and slow your body down as gently as the laws of physics will allow.
And this quote right here, it just nails it. Crash testing is the bridge. It's what allows engineers to learn from the real world and then proactively design cars that are optimized to protect us in the situations we're most likely to face out there.
And that leaves us with a really fascinating question for the future. For the last century, this has all been about how to survive a crash. But what happens when cars get so smart they can avoid most crashes on their own? How do you even test the safety of an uncrashable car? That right there is the next great chapter in the science of survival.